Hey everyone, it's Mrs. Stevenson here again from Renfrewshire Maths team, and today's challenge I hope you'll find quite fun. We're going to do a paper aeroplane challenge. Okay, so for this challenge we're going to fly and test paper aeroplanes. So first off, we need to make an aeroplane to fly. So in the first part of this challenge video, I will show you how to make a paper plane called the Dart, but feel free to make your own version. And then in each slide I will try to give time for you to build your plane alongside me, but you might want to pause the video if you need more time. And after we've made a paper aeroplane, we're obviously going to have to fly them. And this is where we're using our math skills to help collect and gather data. Not much material is needed for this challenge. You just need some paper, ideally a few sheets, because you'll probably have to keep trying. You might not succeed the first time. If you don't have A4 paper like I have here in your house, even a piece of old newspaper will do. Quite a bit of folding involved in making a paper aeroplane, and that can be quite tricky to get right, so take your time. Always try to line up your folds before making a crease. For example, if I was folding a piece of paper in half, I would line up the corners at both sides before pinching the bottom part of the paper and making a crease along. Okay, first step. We're going to start by folding the paper in half lengthwise. Some call this the hot dog style, like this. And then you want to open it back up again and make sure that the crease is visible. That's the folding part here, this crease here. Make sure you can see that down the middle. Next, we're going to fold the cockpit of the paper aeroplane. That's where a pilot would sit in a real plane, so that the flat corners meet at the centre line. Again, try to line it up before you make the crease, and try to make these two folds as even and symmetrical as possible. The edges that you folded should be touching each other, which will then make a triangle at the top of your paper, like this. Then we're going to fold each side in again. Start by pinching the corner of one side like this and fold it over to meet the centre line. Then fold the other side in to meet in the middle so that you've got a shape like this. Next, we're going to fold the paper aeroplane in half inwards, like you can see in the picture, so that it looks like this. The next step is to make the wings. So turn your paper aeroplane around so it looks the same way as mine does in the picture here. Then pinch the top corner and fold it down to meet the edge at the bottom of the plane here. So it should then look like this. And then we're just going to do the same at the other side so that it looks like this. So that's your paper aeroplane ready, but if you want, you can add in this optional step, and that is to fold up the edge of the wings like this on each side. Okay, now for a challenge. We're going to test our paper aeroplanes to see how well they fly. And there are a few things we could look at for this. We could see how far do they fly, so that would be the distance. We could test how long the paper aeroplane is in the air for. And if we want to, we can then calculate the speed that the paper aeroplane travels at. So if we want to test the distance, then each time we throw the paper aeroplane, we measure how far it flew and record it in a chart like this. Now when you're measuring the distance, you might be able to measure it in metres or metres and centimetres, or just in centimetres, in which case you put that on your chart. If you don't have any tools handy to be able to record the metres and centimetres, then you can use another unit of measurement, maybe the length of your feet, for example, how many footsteps along it is. Just make sure you're consistent throughout. So for each throw, measure it in the same way. So for example, on my first throw, I'd write throw 1 in there. My paper aeroplane flew 352 centimetres, but on my second throw it flew 302 centimetres, and then in my third throw it flew 310 centimetres, and then I would keep going. Now, if you've learned how to calculate averages, then you might want to work out the average distance your paper aeroplane flies by adding up all of the distances and dividing by the number of throws you have. So for example, for this chart here, I have 3 distances recorded, so I would add up 352, add 302, add 310, and that gets me to 964, and then I would divide it by 3, as I have done 3 throws, and using a calculator, that gives me 321.33. So that means the average distance my paper aeroplane flies is 321.33 centimetres. Now it's easier to calculate the averages if you have it all in centimetres. So if you've recorded it in metres and centimetres, you might want to convert it first of all into centimetres. If you've recorded it in feet, then your average would come out in the number of feet you have. Maybe you want to measure how long your paper aeroplane can stay in the air for, in which case you would draw out a chart like this. Now when you're timing it, if you have a stopwatch or access to a phone that is a stopwatch, you can get an accurate recording, but it's okay just to count in seconds. So for example, my first throw, I counted 8 seconds that the paper aeroplane was in the air for before it landed. My second throw, it was 7 seconds. And then on my third throw, it was in the air for 6 seconds. As in the previous slide, I could then work out the average if I know how to do this by adding up the 3 timings and divide by 3. Now for an added challenge, you might want to calculate the speed. To calculate the speed, we need to know both the distance and the time. And there is a formula that mathematicians and scientists use to do this. To calculate the speed, you divide the distance by the time, and this will give you the average speed. So let's look at this chart as an example to help us. So this timer chart has 4 columns: throw, distance, time in the air, and speed. So my first throw, I measured 352 centimetres, and the time in the air, my plane was 8 seconds. So to calculate the speed that my plane travelled at, I would divide 352 by 8, and that gives me 44. So that means my plane travelled at 44 centimetres per second. Well, it's just about time now to go and start flying your paper aeroplane and collecting all your data and seeing how well it flies. After you've done it quite a few times though, you might want to add in some modifications to your paper aeroplane and see if that makes a difference to how well it flies. Here are some ideas. You could add a paper clip either to the nose of the aeroplane or move it around elsewhere. Maybe a little bit of sellotape. Does it make a difference if you fly your paper aeroplane outdoors or indoors? Does it make a difference if the paper aeroplane is heavier at the front or at the back? Try it out and see. Or what about trying different folds or different types of paper aeroplanes? This is a great free website called Fold and Fly, and it has instructions for all different types of paper aeroplanes. Why not have a go at making some of these and testing how well they fly? And then you could use your chart to record each plane rather than each throw. Well, have fun, and we would love to hear all about your paper aeroplanes and how well they flew, either by their distance, time in the air, or maybe you calculated their speed. Please share any pictures of the planes that you make and any data you use to judge how well they flew with us on Twitter at #AttainRen, #TeamRenMaths, or you can email us at gw20graylee@glowmail.org. Get flying!